Hey space fans, welcome back to the channel. Today, we're diving into a story that has astronomers buzzing with excitement and a little bit of mystery. We're talking about the Comet 3I ATLAS and its first ever flyby of Mars. The images coming back are spectacular, but they're also hinting at something, well, a little odd. Let's break down what's happening millions of miles away. So, what is 3I ATLAS? First off, the I in its name stands for Interstellar, meaning this isn't your average comet from our own solar system. This visitor is from another star system entirely, making it an incredibly rare and precious object for study. Atlas, which stands for the Asteroid Terrestrial Impact Last Alert System in Hawaii, was the first to spot it. Since then, space agencies around the world have been tracking its journey through our cosmic neighborhood. It's only the third interstellar object we've ever confirmed after Oumuamua and Borisov. So you can imagine the scientific excitement. Each one gives us a unique sample from a distant part of the galaxy without ever having to leave home. Now, let's talk about the main event, the Mars flyby. Several of our robotic explorers at Mars, including the Mars Reconnaissance Orbiter and the Curiosity rover, were perfectly positioned to get a front row seat. They turned their high-powered cameras and scientific instruments towards Atlas as it zipped past the red planet. This was a huge deal. It is the first time we've ever been able to observe an interstellar comet up close with Martian assets. This coordinated effort was a masterpiece of mission planning, redirecting valuable resources to capture this fleeting moment. Think about it, rovers designed to study Martian geology were looking up at the sky to witness an alien visitor from another star. How cool is that? Okay, let's get to the juicy part. The first images started trickling back to Earth, and while they were stunning, they also revealed something unexpected. Comets, as you know, are basically dirty snowballs. When they get close to the sun, the ice heats up and turns into gas, creating a glowing coma or atmosphere around the nucleus and along. Beautiful tale. The initial observations of 3I Atlas showed this classic cometary behavior. The images from Mars, however, told a slightly different story. Instead of a single, uniform coma, the new, high-resolution pictures showed strange clumps and jets of material being ejected from the comet's nucleus. It wasn't a smooth, steady release of gas and dust. Instead, it looked like the comet was sputtering, almost like an old engine struggling to start. Some regions of the nucleus were far more active than others, creating these bright, asymmetrical bursts. This isn't entirely unheard of in comets, but the pattern and intensity on 3I Atlas were peculiar. It suggests that the surface of this interstellar object is incredibly diverse and not at all uniform. So, what could be causing this? Scientists are exploring a few fascinating possibilities. One leading theory is that 3I Atlas has a very lumpy composition. Imagine a fruitcake, but instead of fruit and nuts, you have pockets of different types of ice, like water ice, carbon monoxide ice, and frozen nitrogen, all mixed with interstellar dust. As the comet rotates and different parts face the sun, these various pockets heat up at different rates. The more volatile ices, like carbon monoxide, would vaporize explosively when exposed to sunlight, creating the powerful jets we're seeing. This lumpy model would explain the irregular, sputtering activity. Another hypothesis, and this one is even more intriguing, is that 3I Atlas might be a fragment of a much larger parent body from its home star system. Perhaps a larger, planet-like object was shattered by a cosmic collision long ago. If Atlas is a piece of that ancient cataclysm, its structure could be a chaotic mix of core and crust materials. This would mean its composition is not just lumpy, fundamentally fractured and diverse. By studying these jets, we can essentially perform a remote chemical analysis, trying to piece together the history of whatever alien world it came from. The data we're getting is a chemical fingerprint from another solar system. This brings us to the really big question. What does this all mean for our understanding of the universe? Well, it's huge. Studying interstellar objects like 3I, ATLAS is like being an archaeologist of the galaxy. Each one is a time capsule from a different planetary construction site. If they all look different, it tells us that the processes that form planets and comets might not be the same everywhere. Our solar system might have formed in a very particular way, while others followed a completely different recipe. The sputtering of 3I ATLAS, for example, suggests that the building blocks in its home system were not well mixed. Compare that to comets from our own Oort cloud, which often have a more uniform composition. This could imply that the protoplanetary disk where Atlas was born was more turbulent, or had a different chemical gradient than our own. These subtle clues help us refine our models of planet formation across the galaxy. We're moving from having just one data point to our own solar system to having multiple examples. It's like trying to understand what a house is by only ever seeing your own, and then suddenly getting to see pictures of a cabin, a skyscraper, and a castle. And the story isn't over yet. As 3I, Atlas continues its journey away from the sun and back into the interstellar void. Telescopes like the James Webb Space Telescope will be watching. Webb's incredible sensitivity will allow it to analyze the chemical makeup of the gas and dust in even greater detail. It can detect trace elements and complex organic molecules that might be locked within the comet's ice. Are the building blocks of life, like amino acids, common in other star systems? 3-1, Atlas could hold the answer. We're living in a golden age of astronomy. Well, we're not just looking at distant stars, but we're getting visitors from them delivered right to our doorstep. The weird, sputtering behavior of 3I. Atlas isn't a problem. It's an opportunity. It's a puzzle that challenges our assumptions and pushes us to ask deeper questions about our place in the cosmos. Every strange jet and unexpected clump of dust is a clue. A piece of a story that began light years away and billions of years ago. What do you think is causing the strange behavior of 3I Atlas? Is it a lumpy interstellar fruitcake or a fragment of a shattered alien world? Let me know your theories down in the comments below. I love reading your ideas. Thank you so much for joining me on this cosmic journey today. If you enjoyed this deep dive into the mysteries of interstellar comets, please hit that like button and subscribe to the channel for more space stories. Don't forget to ring the notification bell so you never miss an update. Until next time, stay curious and keep looking up.